SSA stands for side-side angle. Thus, the information given in an SSA triangle is the measurements of two sides of the triangle and the degree of the angle opposite one of those sides. In this explanation, these lengths will be labeled lowercase a and b, and the angle will be labeled uppercase A. SSA cases are often very tricky as there are 6 possible outcomes with the information given. When we use the term solution, we mean how many triangles can be formed with the given information. There are many smaller measurements that can be solved for, such as the degrees of angles or the lengths of sides that can be solved for, but the solution is how many triangles the measurements can form.
The possible outcomes are that there is no solution because A is less than B sine A, there is no solution because A is less than or equal to B, there is one solution because A is equal to B sine A, there is one solution because A is greater than or equal to B, there is one solution because A is greater than B, or there are two solutions because B sine A is less than A, which is less than B.
In possibility number 1, the reason why the triangle has no solution is that the information given in the problem does not form a triangle at all. This is due to the fact that one side of the triangle is not long enough to complete the triangle. In order to prove this, we must compute the height of the triangle. This is done by drawing the height, effectively making a right triangle within the triangle. Then we can use the sine of angle A to calculate the length of the height. As the height is opposite angle A, and we already have the length of the hypotenuse, sine of A is the height over B. If we multiply both sides by B, then B sine of A equals the height. Therefore, A is less than B sine A becomes A is less than H.
Let's give an example. Let's say that angle A equals 30 degrees, side A equals 4, and side B equals 10. The first step to solve this triangle would be to compute the height of the triangle. To do this, we can set up the equation of sine A, which is sine A equals h over b. When both sides are multiplied by b, h equals b sine A. When we plug in the values for a and b, the equation becomes h equals 10 sine 30, which simplifies to 5. Thus, a is less than h becomes 4 is less than 5, which means there is no solution.
Possibility number 2 also has no solution. This is due to the fact that angle A is obtuse and that A is less than or equal to B. Because the angle is obtuse, side A is too far away from side C to ever intersect with it. As a result, side A will just keep rotating around its axis without ever intersecting with any other side, forming no triangle at all. Thus, there is no solution.
To solve an SSA triangle with one solution, you can use a law of sines, which is A divided by sine A equals B divided by sine B equals C divided by sine C. Then, as we know that all angles add up to 180 degrees, we can use the two angles to find the third. Finally, we can use the law of sines again to find the third side. Let's apply this to an example problem. In the SSA triangle, we know angle A equals 126 degrees, side B equals 12, and side A equals 8. We first use the law of sines to find angle B. The equation would equal sine 126 divided by 8 equals sine b divided by 12. We then will cross multiply, turning the equation into 12 divided times sine 26 equals 8 times sine b. Then we divide both sides by 8 to get the sine of b alone. The answer turns out to be b equals 33 degrees. Next, we add 126 degrees and 33 degree and subtract the answer by 180 to find angle C. The answer for angle C is 21 degrees. Finally, we use the law of sine again to find side C. The equation would equal 12 divided by sine 126 degrees equals C divided by sine of 21 degrees, which is equal to 5.32. There is only one answer because side B only connects to the other side in one place. There is no other possible answer for angle A or C because angle A is equal to 126 degrees and a triangle cannot have two angles greater than 90 degrees.
In possibility number 5, there is one solution. This is due to the fact that angle A is obtuse and that A is greater than B. Because side A is greater than side B, it is long enough to intersect with side C, forming one triangle. Thus, there is only one solution. From here, you can solve this SSA triangle the same way it was solved in possibility number 3. First, you can use the law of sines. Then, second, as we know that all angles add up to 180 degrees, you can use the two angles to find the third angle. Finally, you can use this law of sines again to find the third side. How to solve an SSA triangle with two solutions.
First, if C times sine of B is less than B and less than C, that is, if the height is less than the two given lengths, then there are two solutions in this side-side angle triangle. We start by using the law of sines to find angle C. Sine of C over C equals sine of B over B. Then, sine of C equals C times sine of B divided by B. Then, angle C equals the inverse sine of C times sine of B divided by B. Now, we have the first possible angle of C. Next, we use the triangle sum theorem to find angle A. Angle A equals 180 minus angle B minus angle C. Lastly, we can use the law of sines again to find length A. A over sine of A would equal B over sine of B. A would then equal B times sine of A divided by sine of B. We found the first solution, but there is still a second one. To find the second solution, we start by finding the second possible angle C. This angle C would equal 180 minus the first angle C. Once again, we use the triangle sum theorem to find our new angle A. Angle A equals 180 minus angle C minus angle B. Lastly, we use the law of sines to find length A. A over sine of A equals B over sine of B. A equals B times sine of A divided by sine of B. We now have our two solutions. Now, I will solve an example side-side angle triangle with two solutions. The given lengths are B equals 14 and C equals 18, and the given angle is angle B equals 50 degrees. Like previously stated, we start with using the law of sines to calculate angle C. Sine of C over 18 equals sine of 50 over 14. Sine of C then equals 18 times sine of 50 over 14. Angle C equals the inverse sine of 18 times sine of 50 over 14. Angle C equals 80 degrees. Now, we use the triangle sum theorem to find angle A. Angle A equals 180 degrees minus 80 degrees minus 50. Angle A equals 50 degrees. Again, we use the law of sines to find length A. A over sine of 50 equals 14 over sine of 50. A equals 14 times sine of 50 over sine of 50, so A equals 14. We have found the first solution to the triangle. It has lengths 14, 14, and 18. It has the angles 50, 50, and 80. But there is a second triangle. To find this triangle, we start by finding the second possible angle C. To do this, we subtract the first angle C from 180. Angle C equals 180 degrees minus 80 degrees. Angle C equals 100 degrees. Once more, we use the triangle sum theorem to find angle A. Angle A equals 180 degrees minus 100 degrees minus 50 degrees. Angle A equals 30 degrees. Lastly, we use the law of sines to find length A. A over sine of 30 equals 14 over sine of 50. A equals 14 times the sine of 30 over sine of 50. A equals 9.10. We have found the second triangle solution. It has the lengths 9.10, 14, and 18. It has the angles 30 degrees, 50 degrees, and 100 degrees.